Hi, my name is Vincent, and today I want to take you all through the August 2019 Geometry Regents. The copy of the exam could be found in the description below. You could download it as a PDF. That way you could follow along. So starting here at question 1, we have line segment AB and line segment A prime, B prime. And the transformation taking place here is a dilation scale factor of 5/2 or 2.5, centered at point P. So for a question like this, you should just be showing up to the Regents, knowing some of the basic formulas, theorems. And one important idea to know is that anytime you dilate lines, the pre-image and the image are both going to be parallel. So if you just go in there knowing that, you'll see that it's going to be choice 2. But it's all right. Let's say you forget that idea, because it's very easy to forget stuff. There's like a lot of stuff to remember for this test. If I were to connect these 3 points, I could rule out the other answer choices. So PA is congruent to A prime. Visually, just looking at this, these are definitely not equal. So 1 is out. This would only be true if the scale factor was 2. Then this piece would be the same, but not in this case when it's 2.5. Now, we also have that AB is equal in length to A prime, B prime, but as long as we scale it with something other than 1, the line is either going to be shorter or longer, so 3 is out. And if we look here, like this is obviously the longer line. So if I were to multiply the longer line, A prime, B prime, by 2.5, it's definitely going to be bigger than the shorter line, so definitely not equal. So just by using a little, process of elimination, some common sense, test taking skills, you could just say it's going to be choice 2. Now for this question here, we have a parallelogram. So what we could do is I'm just going to sketch one. And I'm not going to bother graphing this one because the idea of what we need to do is not too bad once you see what we need to do. And what we have here is the vertices of a parallelogram, and we want to know what the coordinates of P, the point of intersection of the diagonals. So one of the major ideas that you need to know about parallelograms is that the diagonals, when they intersect, they bisect each other. So P, wherever it is going to separate the diagonals into 2 congruent segments for each of them. So that means P is the midpoint of CE and DH. So if we were to find the midpoint of, let's say we do it for CE. So we're going to use this one and this one. To find the midpoint, you just add the x's. You got -5 plus -1. So we're adding those two, dividing by 2, and then we've got the sum of the y values, so 5 plus -1. And we're dividing that by 2 as well. Okay, so 5 plus -1. Let's make that a little neater. 5 plus -1 divided by 2. So that tells us the midpoint, -6 divided by 2 is -3. And 4 divided by 2 is 2. So choice 3. But if you have time on the test, just to play it safe, find the midpoint of the other ones. And what we mean by that, the other diagonal is DH. So if you do 2 minus 8, 2 minus 8 is -6, and we're dividing by 2. And then we've got 5 minus 1 is 4 divided by 2. So the other midpoint is also -3, 2. So that should make you feel 100% certain your answer is choice 3. All right, for this question here, these questions are definitely a bit tricky. This was a kind of an evil Regents. It's surprising it's in August that they made it this difficult, but we're going to take a look at this question. We have some line segment QS. So QS, let's do a better job at that. So Q, and then S is here. And the location of point R is placed in such a way that it splits this line segment into a ratio of 1 to 2. So R is going to be somewhere about here. So if R is in this location, this segment QR is half as long as RS. So what I like to do with these ratio questions is think if there's a ratio of 1 to 2, I'm breaking this segment into 3 parts. So if I break this into 3 parts, see how each part is equal in length? But R is still going to be here because we need QR to be twice as long as RS, which is equal to 2 parts versus QR is 1 part. So this method I find to be pretty effective for these questions. To find my x value in my coordinate for R, I could graph this, but these points are really far away from each other, so it's kind of difficult to see. but Q starts at x equals -9 and S ends at x equals 9. And if I'm breaking this into 3 parts, what I want to do is I'm going to divide the change in x by 3. So my change in x, to go from -9 to +9, that's an increase in 18. So that means I'm going to be counting by 6. So what I mean by that is if we do -9 plus 6, -9 plus 6 is -3, and then -3 plus 6 is +3, and then 3 plus 6 brings us to 9. So that would break the distance in the x's into 3 equal parts. But remember, R is going to be located at this location, because this breaks it into a ratio of 1 to 2. And now if we repeat this process for the y values, we just have to think, where does y begin and where does y end? So the y value starts at 8. And we're not going to write this from smallest to least. We're just going to write it in the order it appears. So we have 8 and we're going down to -4. So now we're going to take the change in the y values and divide that by 3 because there's 3 parts here. The change in the y values is we're decreasing by 12. So for each part, we're decreasing by 4. It's kind of like we're calculating rise over run in a way. So if I keep subtracting 4, 8 minus 4 is 4, 4 minus 4 is 0, and 0 minus 4 is -4. If you mess this up, you're not going to get the number that you end with. So that's how you know like your values are off. But once again, R is located at this location here, splitting this into a 1 to 2 ratio. So then to close this out, all you have to do is just write your x value in place here. So we have -3, and your y value is +4, making this choice 3. You could also plot this on a graph and just try to accurately place this, but I showed it in a separate video to do that when the points are closer together. Like this is a bit of a pain to see. And graph wasn't provided for this question, so you have to use the scrap paper in the back. All right, for this question here, this triangle isn't drawn, but in a moment we're going to draw a few triangles. But the question is the altitudes of a triangle meet at one of the triangle's vertices, so we have to say what type of triangle it is. Now, we're going to show that it is in fact a right triangle, because the altitude to a right triangle, there's 3 of them. One of the legs acts as an altitude because it's perpendicular to the other side, and it meets here at this point. Let's call that point C. And now this other leg acts as an altitude to this vertical side over here. So those the 2 altitudes are already meeting at point C. And then the third altitude would be perpendicular to the hypotenuse of the original right triangle, and that's the location where all 3 altitudes intersect. Now the reason why it's not choice 3, if I were to draw an obtuse triangle, which is really just a triangle that has an angle bigger than 90 degrees, this altitude here extends outside the triangle, and if I were to draw an altitude here, see like here's my 90-degree angle, here's my 90-degree angle, the altitudes intersect outside the triangle. So it's definitely not this one. And this is a situation where they put kind of like a double answer. An equilateral triangle is an acute triangle because all the angles are less than 90 degrees. So this is an acute triangle. So you can't have the same answer twice, so that's why these are out. But in this case, in an acute triangle, the altitudes intersect inside the circle. So choice 1 here. For this question here, we need to know some of this vocabulary. So if DB is a median to AC, the median intersects is a line connecting the vertex to the midpoint of the opposite side. So if B is a midpoint of AC, that means AB is congruent to BC. So I most often like translate this stuff onto a diagram. And we're also told here that AB is congruent to DB. So that means we have 3 congruent line segments here, and we have 2 isosceles triangles that we're probably going to make use of that information. So next thing we're told is that DAB is 32 degrees. So we're going to label the angle DAB 32 degrees. But in an isosceles triangle, the base angles opposite the congruent sides are equal. So this angle is 32, and up here, angle ADB is also 32. So we could solve for just all the angles in this question, but we're trying to find the value of angle BDC up here. So one way of doing that would be to find this angle DBC, which is an exterior angle. So I'm going to just do 32 plus 32 is 64. That's the exterior angles theorem. When I add the two remote interior angles, it's equal to the extension of the third angle. But you could also find that this angle here is like 116 and do 116 subtracted from 180 and you'll get 64. But then same concept as before. We have another isosceles triangle here. DB and BC are equal in measure. So not only is this angle x, this angle down here is x. So then all we have to do to solve, we have 2x because x plus x. And then we have plus 64 equals 180. Just know the sum of the angles in any triangle is 180 degrees. And now we got 2x equals, that's going to subtract to 116. So then here, when we divide by 2, we're going to get x equals 58. All right, now just one thing. Anytime you solve for x, make sure you're actually answering the question, what's the measure of angle BDC? And we labeled BDC as x. So x is, in fact, the answer. Sometimes you have to multiply it by something, so just don't make a mistake like that because those are frustrating. All right, for this question here, we have we're dealing with the circle. So just to save time, this is the equation for a circle. So the algebra that you need to be skilled at here is completing the square. So what we do is we move all the x's and y's to the left side and we leave the constants on the other. And I group them together. So what I mean by that is I have x squared on the left, but I want to group it with, whoops, wrong term. I want to group it with the 8x. So I'm going to subtract 8x on both sides, which gives me x squared minus 8x, and now I'm going to leave a space. The next thing I want to group is the y terms. So we're moving everything else to the left. So I have plus y squared, and to move minus 6y over, I would do plus 6y. And I leave a space. And you're going to see why we're doing that in a moment. And the 39 is just on its own on this side. So the technique is called completing the square because the equation of a circle, it's x minus h times x minus h. So we need whatever, like when this factors the stuff in blue, we need the factors to be identical. So what we do is we take half of the b term. The b term is the coefficient of x. So what we're doing is we're taking negative 8, we're cutting it in half, and we're squaring it. And if we do that, negative 4 squared is 16, which tells us we're going to add 16 to both sides of this equation. And now for the other one, same concept. We're taking half of the b term. The b term in this case is 6. We're squaring it. And 3 squared is 9. So we're going to add 9 now to both sides. So then this problem, the way it's going to close out, the stuff here in blue, the x's, is going to factor to x minus 4 times x minus 4. Let's make that a little neater. So we got x minus 4 times x minus 4, which is x minus 4 squared. And now we've got plus, the stuff in purple is going to factor as y plus 3 times y plus 3. So we could just write this as y plus 3 squared. And now to the right of the equal sign, you just got to add the numbers. 39 plus 16 plus 9 is going to work out to 64. And then the rest is knowing how to go from the, this form here back to center and radius form. So the center, all I like to do when I identify the center is just switch the sign of the number in front of x. So instead of negative 4, the center is going to be at x equals 4. And then instead of positive 3, we got negative 3. Now be careful. This answer choice is pure evil, choice 2. Make sure, remember the equation is in the form r squared. So you could rewrite the constant as a constant squared. 64 is equal to 8 squared, which tells us that our radius is equal to 8. So in this case, question 6 is going to match up with choice 4. For this question here, we're dealing with a parallelogram. And we're given the information that, we have this line segment, which just tells us this is a line. And we have CF bisects angle DCB. So right away what I would do is just mark off angle DCB. I have this angle DCE is congruent to, let's say, this angle ECB. The next thing we're told is that DG, this line, bisects angle ADC. So that would tell us that this angle here and this angle here are exactly the same. And the rest, the two lines drawn in intersect at E. So we also know that angle B is 75 degrees. And what we want to find is the measure of angle EFA. So we're going to call this x, and we're going to try to solve for x. Now, one of the properties you need to know about parallelograms is that the opposite angles are congruent. So angle ADC is also 75, but you see how it's being cut in half. So what we're going to do is we're going to take 75 and divide it by 2. That should be 37 and a half. Yeah, 37 and a half. So here we'll write in 37.5. And then this angle is 37.5 because remember, the angles opposite each other in a parallelogram are congruent. The next thing you need to know is that consecutive angles are supplementary. So that means that angle A and angle B have to add up to 180. So to solve for A, we're just going to do 180 minus 75, which should be 105. Yep, so it's 105. So this angle down here is 105 degrees. And let's see what else we could find. Well, this angle over here, angle DCB, is also 105 because opposite angles are still congruent. But it's being cut in half, so we just divide this by 2. It should be 52 and a half. So we can label this angle here 52 and a half. And same thing here. But if we want to solve for angle X, like let's focus on this quadrilateral. So we want to find this angle here, DEF. So to do that, we're going to find this angle here first, and then that'll be able to tell us what this is over here. So to solve for angle DEC, we have two angles inside of a triangle, so we're just going to subtract those from 180. So we're going to do 180 minus the sum of 37 and a half plus 52 and a half. Which tells us this angle over here has to be 90 degrees. But yet another concept you have to know is that on a straight line you have 180 degrees, so this angle here also has to be 90 because 90 plus 90 is 180. So next thing, the sum of the angles in a quadrilateral is equal to 360 degrees. So we're going to do 360 minus the sum of these three angles. So that tells us here, well, we could set up an equation just so you could all follow. We're going to have x plus, and now we got 105 plus 90, and we got plus 37 and a half. So that's the sum of those three angles, which is 232.5. So we have 232.5, and the sum of x and the other three angles equals 360. So then we'll just subtract this from, oh, I'm sorry, we'll do 360 minus our answer. So 360 minus 232.5, which gives us 127.5. So x equals 127.5, and x represented the angle EFA, which is what we wanted to find. So our answer here to 7 is choice 2. For question 8, the major concept that you need to know is that the slopes of perpendicular lines are negative reciprocals of each other. So that means what we want to do is we have to identify the slope of this line because we want to see a line in the answer choices that's perpendicular to this. So basically we have to know the slope of the given line. The slope is the coefficient of x once you solve for y, and the y-intercept is the constant b at the end. So if we do the algebra, we're going to have 2y equals, and we'll subtract 3x on both sides, so we get negative 3x plus 1, and now just divide everything by 2. And that tells us that the equation in y equals form is negative 3 over 2x plus a half. That means the slope of this line, the coefficient of x, is here, is negative 3 over 2. So if we want to know the equation of a line perpendicular, the slope that we need here would be the negative reciprocal of negative 3 over 2. And a negative reciprocal just tells you to flip the fraction and then change the sign. So if it's negative, we're going to make it positive. So really what we have to do here is say which answer choice has a line with the slope of 2/3. And if we look, the only one that fits the description is here because the slope here is 2/3. Everything else, like this one's no good because the slope is 3 over 2. And this answer choice is actually just what we solved for y. So that one's out, and then this one is also out. This would just be a slope that's a reciprocal of the other. So in this case, 8 is choice 1. Okay, for question 9, we have to know the transformations here. So for this kind of question, you really just want to go through the answer choices and say why they're no good. So for 9, 1 is no good because if I were to make the diagonal line y equals x and then kind of turn your head 45 degrees, you'll see that this does not flip over this line of, like this is not a line of symmetry for this shape to this shape. Like this wouldn't land perfectly on top of this. There's actually going to be a rotation going on here because like the direction is changing if we look at the one triangle to the next. But it is going to be choice 2, and I'll come back and explain why it's choice 2, but what we could do is say why the other choices are no good. So if we were to reflect over the x-axis first, so if we reflect, that's 2 units down. This is not an exact replica, but the shape would look something like this, and the right angle would be in this corner. So if I slide it over to the right now, you see how the right angle would be in the top right corner, but in this triangle it's in the top left. So choice 3 is no good because of that. The reason why choice 4 is no good is if I reflect over the x-axis, well, I shouldn't have erased that because it's the same thing that we had started with. So I get a triangle that looks kind of like this. But then if I reflect over the line y equals 1, now I'm just going to be flipping back up into this quadrant over here, quadrant 2. So choice 4 is out. So just by process of elimination, choice 2 is the one. But a way of verifying this is that at 1, 0, if I were to connect each point with its image and go from like one point to the next, so like C and T map to each other, see how it goes right through the center? And if I repeat that for the other ones, like A would map to R, it also goes through the center of rotation, and same thing when B maps to S. So that's one cool way of seeing it. Another way, which would not really be practical for the regents, but if I were to make a circle from here, the circle with center 1, 0 going to point C, CT would act as a diameter of this circle. And if I repeat that process, let's say for A, you see how A and R would act as, AR would act as a diameter for this circle, and then if I do it for B, same thing. BS would act as a diameter going through 1, 0. So definitely choice 2 here. Now for question 10, we have another kind of like a repeat topic where I have dilations again, but now the scale factor is 4 centered at the origin. So if we're doing a dilation of 4 centered at the origin, that means any point when we dilate it is just going to be 4 times the x and then 4 times the y. So then, same idea as before. When we dilate lines, dilated lines are parallel, and we need to know that parallel lines, so we have parallel lines have equal slopes. So parallel lines have equal slopes. So what that tells us is that whatever our answer is, the slope of our line in our answer has to have a slope of -1/4, which means these two answer choices are out. So what we need to be able to do is identify the y-intercept. But for the given line, before we dilate the line, the given line has a y-intercept of 0, -2. If you look, the y-intercept, when we look at y equals mx plus b, the constant at the end is the y-intercept. So x is 0 and the y-intercept is -2. So if we were to dilate this by a scale factor of 4, that would send us to 0, -8, because we're just going to do 4 times 0, 4 times -2. But this tells you that the image, the y-intercept, is in fact -8, so we're going with choice 1 here. And on a different part of the test, they might ask you to write the equation of the dilated line. So if they wanted an equation, we would say the slope is -1/4, and then the y-intercept is -8. So this would be the equation of the line if that's what they wanted. So in this case here, let's actually circle our answer, is choice 2. Oh, I'm sorry. Let's correct that. We already circled our answer as choice 1, which had the y-intercept of -8. The y-intercept of -2 is the original line, so that wouldn't work here. So choice 1 for question 10. All right, we have a square with side length 7. So let's go ahead and draw a square. And the name of the square is square math, and we're rotating around side AT. So let's just label all of this. And the side lengths are all 7 inches. So if we're going to spin around side AT, the shape that we're going to be forming is a cylinder. Because if we were to rotate this in like a circular motion, the shape that's formed is a cylinder. Just think, like if you had like a can of soup and you peel off the label, it's going to look like a rectangle. But if it was constructed a certain way, like it could have like, you know, like a square shape too. But just you could see it this way also. Like AT is here, and then H is here, M is here. And what's going on here is like we're spinning this around in a circle. So if 7 is over here, 7, you have to be careful, represents the radius because it's going from the center to the circumference of the cylinder. So in this case, it's acting as a radius. So we have not a cone, we have a right cylinder. So we'll get rid of the ones that say cones, and the radius in this case is 7 inches. The only way we could wind up with choice 2 would be if instead of rotating around AT, let's say we rotated about the midpoint of MA and HT. So like let's say, I don't know, like this was point X and point Y over here. If we rotate around this, then we would have a situation where the diameter of the cylinder is 7 units long if we kept spinning around this. But because we spun around one of the sides, it's a different situation altogether. So in this case, 11 is choice 4. For question 12, we want to find the area of the shaded region. So the missing angle, there's 360 total. The missing angle is 240 degrees. So in a way, like we're just taking a fraction of the area. The fraction that we're taking the part, well, we don't need to write the degrees because we're going to write it as a fraction. Whoops, let's fix this. So we have 240 degrees here, but the part we're taking is 240 out of the total 360 degrees. And we're taking that much of the area. And the area of a circle we get by finding pi r squared, where in this case r is equal to 9 units. So it's going to move this whole thing over. So once again, we're taking 240 out of 360 of the area. This reduces to 2/3. So what we're doing is multiplying 2/3 by the area. So if you just want to use a calculator here, just multiply the numbers, leave the pi out because your answer has to be in terms of pi. And we got 240 over 360, that's the 2/3. Multiplying by 9 squared, which is 81. So that tells us we have 54 pi. If we want to work this out without a calculator, just reduce that fraction to 2/3. And then we have pi times 81. And then 81 over 3 reduces to 27. 27 times 2 is 54. So we have 54 pi for question 12. Now for this question here, this is a properties of parallelograms question. So once again, I said this towards the beginning of the test, but going into an exam like this, you should have the major properties kind of memorized because there are some questions where they just kind of force you to use a specific property of a parallelogram. So definitely want to make sure going into a test like this that you memorize the list of them. But we have QRST, and if we read through the answer choices, we're looking at the diagonals QS. So we have QS connecting here and RT. And we read through these and let's see which sides are the most relevant here. It looks like choice 3. We have QR is congruent to TS. And we have QT is congruent to RS. We're saying which statement would always prove that this quadrilateral QRST is a parallelogram. So when you're trying to prove a quadrilateral is a parallelogram, this in words is saying that both pairs of opposite sides are congruent. So this is the one. The reason why this one is no good, let's say choice 4, QR is congruent to TS and QT is parallel to RS. That could model a situation where you have like an isosceles trapezoid. So let's draw that a little better. So something like this. If I were to draw an isosceles trapezoid, see how like in that situation I have Q, so let's see, Q, R, S, and actually, you know what, let's do the lettering a little different. We have Q, R, so I'll put the T here, so T at the end, let's see, R, S, T, hopefully this one works. QT is parallel to RS, so there it is, and QR is congruent to TS. So this could model an isosceles trapezoid, so 4 is out. And you could go through a similar argument for the other ones here. Like if you call this point M, QM is congruent to SM, QT is congruent to RS. Like one thing we could use to prove a quadrilateral is a parallelogram is that the diagonals bisect each other, but that's not modeled by this. And then we have T, QR, and QRS are supplementary, but this shape also models it. TQR, call that X, and then QRS is Y. The same side interior angles of a trapezoid are supplementary. So like X and Y would be would add up to 180, and so would this angle here, T and angle S. So that's why this one's no good. But just know your properties, and it's definitely choice 3. So for this question here, we're dealing with we have a golf ball, so we'll just draw a circle to model this. The diameter is 1.68 inches. Now right away, anytime they give you the diameter, they're just trying to test you to see if you're going to divide by 2. Because to find the radius, just divide the diameter by 2, and the radius is equal to 0.84 inches. All right, now they're giving us the density of the golf ball to say, kind of like it's going to help us find the weight. So we have 0.6523 ounces per cubic inch. And we want to know what's the weight of the golf ball to the nearest hundredth of an ounce. So the weight comes from density, and the density will break the rules of physics. Technically, like mass and weight are different, but we'll just match it to this word problem. So we're going to say density is, instead of mass over volume, we'll say the weight over volume, so it matches the context of the question. So then our weight is just going to be the density of the ball times the volume of the ball. So to find the volume, we're dealing with a sphere. We'll assume that it's like a well-constructed golf ball. And the volume of a sphere is 4/3 pi r cubed. So if we plug in the volume, we just type all that in, 4/3 times pi, which is that second up arrow button, or caret they call it. I don't know why they call it caret. All right, and then 0.84, but the radius is being raised to the 3rd power. And if we work that out, the volume is 2.4827. So 2.4827, and the units are cubic inches because we had 0.84 inches being raised to the 3rd power. So then when we want to find the actual weight of the ball, now we just multiply. The density is 0.6523 ounces per cubic inch, and we're just going to multiply that by our answer over here, the 2.4827 cubic inches. So then we already have this in the calculator, so just do times 0.6523, and to the nearest hundredth, that's going to be 1.62. And it's ounces. The reason why I like to write the units out is so you can see the cancellation. Cubic inches cancels out with this cubic inch over here, leaving you with just ounces. So in this case, 14 is going to be choice 2. All right, for this question here, this one is definitely a bit tricky. So we're dealing with, we got Chelsea over here. So there's Chelsea, and she's standing near a tree. So there's the distance from Chelsea to the tree. She's sitting 8 feet from the foot of the tree. So this horizontal distance is 8 feet. And then they're telling us here that the angle of elevation to the top of the tree. So we'll go ahead, I'm just going to draw a quick tree here. And anytime they say angle of elevation, that's going from like this horizontal piece here, and it's going upwards like this. All right, let me just move all this stuff down so we have more space. So we're just going to complete this right triangle diagram. And what other labels were we given here? The angle of elevation is 36 degrees. So 36 degrees. And all right, so if her line of sight starts 1.5 feet above the ground, so like her eyesight is here, the distance from like her eyes to the ground, this vertical distance here, is 1.5 feet. So if we're trying to find how tall the tree is, or the height of the tree, what we have to do is, let's say we call this y, this distance here. When we solve for y, we're going to have to add 1.5 to it, because that distance is equivalent. 1.5 is the distance, like let's say the ground is here, and then like that's where the tree is like going into. We're going to do 1.5 plus y. So the trig functions we need to know, sine, cosine, and tangent. This mnemonic helps. We know the adjacent side, the 8 feet, and we're trying to find the side opposite. So when that phrase is bouncing around your head, you're going to use tangent, because we want to know the opposite and we know the adjacent. So we're doing tangent of the angle, 36 degrees, is equal to the ratio of the side opposite, which is what we're trying to find, y, over the adjacent side, which is 8. So then y is just equal to 8 tangent of 36 degrees. And if we type that in, make sure you're in degree mode too, because that will ruin your day. 8 tangent of 36 is 5.812. But the actual height of the tree, we have to remember, don't circle this one. That would be a tragedy. You have to add 1.5 to your answer, because it's 1.5 plus y to the top of the tree. So just do plus 1.5. And then we got 7.3-ish, which rounds to the nearest foot to 7. So 15, we're going with choice 2. Now for question 16, what we're looking at here is we have a right triangle diagram, and we have an altitude drawn to hypotenuse AB. So if AB is a hypotenuse, that means that angle C is a right angle. And if CD is an altitude, that means that we have right angles down here. And one consequence of this is that, let's say I call this triangle 1, triangle 2, and the original one was triangle 3. All three of those triangles are similar, which means their sides are in proportion. For questions like this, there's another question like this that shows up later, so I'll just show one of the methods. You could use concepts of trigonometry to help you answer this, because one consequence of having similar right triangles is that the trig ratios, sine, cosine, and tangent, have to be the same no matter which triangle you're looking at. And let's say, for argument's sake, so that we have an easier time labeling all this and keeping track of the angles, let's say I call this angle here 30 degrees, and this one over here is 60 degrees. So if we labeled it this way, not drawn to scale, but because these triangles are all similar, that means they have the same angle. So in triangle 1, if I have, the original triangle was 30, 60, 90. So in triangle 1, I also need 30, 60, 90. So if I have 90 here and 30 here, this would have to be 60. And then in triangle 2, I also need 30, 60, 90. So that missing angle would have to be 30. So then let's say I go choice by choice. AD and AC is side lengths in triangle 1. So I think about, how could I build the ratio AD over AC? Well, if I use angle A, the 30-degree angle, what we could do is look at cosine of angle A is equal to the side adjacent to 30 degrees, which is side AD, over the hypotenuse AC. So now I'm just going to repeat that in the triangle that has sides CD and BC, which is triangle 2. So then I just have to say, well, which angle would be equal to angle A? And it would be this one up here, DCB. That's why I put the numbers there. It just helps to follow. So then here, if I do cosine of this angle in the second triangle, triangle 2, the ratio, the side adjacent to that angle is CD over the hypotenuse of the second triangle, which is BC. So right away, that shows us that it's choice 1. If I were to use like that same process to rule out one of the other answer choices, like I'll just say the other two here are wrong, but I'll just check it for choice 2 so we don't get too repetitive here. But AD and CD would be if I were to use tangent of angle A. So tangent of angle A in triangle 1 would be CD. Better yet, we're going to say it would be tangent of the 60-degree angle up here. So if I wrote tangent of 60, so you could better follow it, opposite of the 60-degree angle would be AD. Over the side adjacent to the 60 would be CD. But then you see how BD and CD are in the second triangle? So if I did tangent of the 60-degree angle here, this time around I would get CD over DB, which is basically this thing is flipped. So that's why this one is wrong. All right, so this might be helpful for you, but otherwise check out the other method that shows up later at the end of the multiple choice. Now for 17, this question was a real pain, especially how it was labeled. It was kind of sloppy. But what we want to do is find the area of the countertop, and it's this wacky shape here. It's basically like two rectangles joined together. So like, yeah, we're looking at two rectangles, but in one of the rectangles we have like another rectangle cut out. So we have to find the area of this rectangle and minus the area of the sink, and then add that to the area of the second rectangle here. But right away, for this rectangle, this value up here would have to be 2 feet. And this was labeled a bit sloppy, but 8 feet represents the entire length of the countertop going from this point to this point. So if the whole thing is 8 and this piece has to be 2, that means this piece down here, in this location, so this distance from here to here would have to be 6, which means this distance from here to here is also 6 feet across. So if we start this off, the area of this first rectangle, I'm doing 2 feet times 2 feet, so it's 10 square feet. But now for the area of the second piece, what we want to do is we're starting off like the area of, let's say, rectangle 1 is 2 feet times 6 feet, which is 12 square feet. But I have to subtract out the area of the sink. So one thing right away that they try to trick you with is that these numbers are way bigger because they're in inches. So if we convert 21 inches, we're just going to divide it by 12 in a way, but this is like the concept of why we could just divide by 12, because I'm converting the units. So then in terms of feet, the area of the sink, well, the length I could say is 21 over 12. So I got 21 over 12 feet. And then the height or the width, you could think of as 18 over 12 feet. So same way we're converting that piece. So then the calculator will tell us here what that value is. We got 21 over 12. And we're multiplying that by 18 over 12. So we work that out here. We got 2.625. So the area of the sink in square feet is 2.625 square feet. So now to combine this all, remember what we said, the area of the countertop, we're just going to add the 12 square feet as the area of this rectangle, plus 10 square feet, which is the area of the second one. But now we have to subtract the area of the sink. So then the area of the countertop, if we work this out, this is going to be 22 when we add those. So we're going to do 22 minus our answer, which gives us 19.375 square feet. And we're rounding to the nearest square foot. So it's the nearest whole number. That's going to round to 19. So 17 is choice 4. All right, for this question here, we have triangle ADE, and B and C are connected on the congruent sides of, this is an isosceles triangle ADE, so AD and AE are equal. And it's connected in such a way that this triangle is also isosceles. So we have like AB is equal to AC, and we have AD is equal to AE based on the given information here. So for these kind of questions, what I like to do, because this is going to turn into a proportion situation, if like both of these triangles are isosceles, because of like this connecting line segment, that means they're both similar. So I'll draw the small triangle and the big triangle. So AB is equal to 10. So this is like triangle ABC. So I could call this piece 10. We have BD is equal to 5. So if this is triangle ADE, like drawn separately, if BD is equal to 5, that means the entire thing is 10 plus 5. So AD is equal to 15. And we're also told that DE down here is equal to 12. So if this is equal to 12, we want to know the length of BC. We could just set up a proportion. So we got the left side compared to the bottom side. So we're going to set up 10 over x, and we're setting that equal to 15 over 12. So if we work this out, 15x is equal to 120. Divide both sides by 15, and that's going to give you x equals 8. And remember, x represents the length of BC, which is what we're trying to find. So x equals 8 is going to lead us to choice 3. So 18, we're going with choice 3. All right, for this question here, if you know the concept of cofunctions, sine and cosine are cofunctions, which means that they are equal if you evaluate them at complementary angles. And since A and B are complementary, that means that this is going to be choice 1. But if that didn't do it justice, don't worry. Like, you don't have to memorize all the rules. You just have to know how to do like the basic concepts really well. So if you just go through the answer choices, if you were to find sine of A, sine is the ratio of the opposite to the hypotenuse. So if we go at A, opposite of A is 12. The hypotenuse is 13. But if you look at cosine of B, cosine is adjacent over hypotenuse. So B is here. The side adjacent is 12. The hypotenuse is fixed at 13. So since they give you the same thing, that also shows why this is it. If you run the others through, they're all going to, they're not going to work. So 19 is going to be choice 1. For question 20, we have right triangle RST. So let's go ahead and draw a right triangle. And we're told here altitude TV is drawn to the hypotenuse RS. So we're going to label this hypotenuse RS, which means the right angle occurs at T. And the name of the altitude is TV, so we'll go ahead and just draw it in. Let's just make that a little bit neater. We're going to draw in the altitude and name the point of intersection V. And the next thing we're given is the value of the sides. So RV is equal to 12. We have RT is equal to 18. And we want to know what is the length of SV. So we'll call this X. So one way of doing this question, or I don't know, one of like my preferred ways, is if you just think of a random right triangle. Now, unless this is an isosceles right triangle, one of the legs is going to be shorter than the other leg. So I drew this in such a way that RT is visibly shorter than TS. It doesn't have to be drawn to scale, but drawing it that you could identify one side as the short leg and long leg. So wait, hang on, let's write that a little better. Whoops, let's try again. So writing this in such a way that one side is clearly the short leg and long leg will just help you set up the proportion correctly. So you see here, like we know 12 and 18 in triangle RVT. And 12, if we look, represents the short leg. TV is visibly longer. So we're going to compare 12 and 18 represents the hypotenuse. So in this first ratio for triangle RVT, we just compared the short leg to the hypotenuse. So then we move to one of the other triangles, and we're going to, in fact, use the main triangle RTS. Now, the letters aren't necessarily in corresponding order for similar triangles, but this short leg, long leg, hypotenuse concept is going to help us answer this. But as we could see in the main right triangle, RT is clearly the short leg, so that's going to go first because we're comparing short leg to hypotenuse. And the length of the hypotenuse in the main right triangle is 12 plus x. We just add together 12 and x. So then to solve for x, we just have to do the algebra. 12 times 12 is 144. 12 times x is 12x. And now we're just doing 18 squared. And whoops, hang on a sec. Let's fix that. 18 squared is 324. So this is equal to 324. And now we're going to subtract 144 on both sides. And over here, we could use the calculator, but this is going to be 0, and 32 minus 14 is 18. So we got 12x equals 180. And then once we divide by 12, this is going to work out to x equals, looks like that's going to go in 15 times. So we'll just double check, 180 over 12, but I'm pretty sure that's 15. Yep, 15. So then be careful, make sure you're actually answering the question here. The value of x is equal to 15, and since we're looking for SV, and SV is modeled by x, x is in fact our answer here, so choice 2. For question 21, we're dealing with the right square pyramid, so we'll just go ahead and draw out a square pyramid. So I draw like a slanted looking square to make it look three-dimensional, and then drawing kind of like a triangle from here to here, and then we're going to connect this point here, and you can imagine that fourth line going to the top. And they're telling us the base edges are 64 centimeters each. So this is 64, this is 64, and all around. And we're told that the slant height is 40 centimeters. All right, so the concept here is like we need to use like a Pythagorean theorem concept. So if the base edges are 64 centimeters long, if we drop down the altitude is going to go right to the center here, and then the distance out this way is going to be half the side length. So if the whole thing is 64, this distance is 32 centimeters, and the slant height represents the distance from the top of the pyramid along the surface of the pyramid to the bottom here. And we're just going to go ahead and label that this piece is 40 centimeters. But one thing to be careful of, they're definitely going to have an answer choice waiting for you. When you go to find the volume of a square pyramid, you're using 1/3 area of the base times the height. Do not use the slant height as the height. All right, what you need to solve for is the missing value h, which is basically like we're finding the missing side of a right triangle. Now we could use Pythagorean theorem here, but this skill is actually transferable to the SAT. This is actually going to be proportional to a 3, 4, 5 triangle. Let's say I want to find a triangle similar to a 3, 4, 5 with the scale factor of 8. If I multiply all of these sides by 8, I'm going to have 8 times 3 is 24, 8 times 4 is 32, and 8 times 5 is 40. So you see how like we have 32 and 40 here, but because this is similar to a 3, 4, 5, the missing side, the height, is 24 units. So we're going to have h is equal to 24 centimeters. All right, otherwise you could just do 40 squared minus 32 squared and take the square root. That'll also solve for h, but I like this way better. It's just like a little bit faster. So now we have 1/3. The area of the base, we're going to look at the original square pyramid. The area of the square base with side length 64 centimeters is 64 centimeters raised to the second power, and then the height we just solved for is 24 centimeters. So then the volume here, the units are going to be in cubic centimeters, and we are, they have the decimal values here. They didn't tell us to round to anything in particular. But now we just multiply this all out, so we got 1/3 times 64 squared, and then that quantity times 24. So that's 32,768. So 32,768 cubic centimeters, which matches choice 3. All right, question 22. Most of the challenging questions are saved for the end, but 22 is like a deceivingly easy question for this part of the test, which will sometimes make you second guess things. But when you have intersecting chords, the product of the segments are equal. So what that tells us here is the product of the segments. We have segment RT. So we have RT times TS is equal to the product of the other two segments formed, PT times TQ. So we have PT times TQ. So this is just a theorem that you need to know. that the product of the segments formed are congruent, and that matches what we have here at choice 4. Now for 23, we need to go through a process of elimination here. I mean, if you just know, oh, this rhombus has a line of symmetry at the y-axis, and you just recognize that as the equation x equals 0, then awesome. Like, then this is your answer and you are done. But it's a good practice to rule out the other answer choices, like why is this answer choice 1 no good? If I were to rotate this figure 180 degrees counterclockwise or clockwise about the origin, this point down here would wind up here. So my rhombus would start going in this direction, which clearly doesn't overlap with the original rhombus. Like when we want to carry the rhombus onto itself, that means after the transformation, we should be looking at the identical figure here. So that means choice 1 is out because of that. Choice 2 is a very cruel answer. This one throws students off because if you know how to graph this, 1/2 x plus 1, we have a y-intercept of 1, and we have a slope of positive 1/2, so we rise 1 and run 2. So that line would actually go this way. And people think like, oh, it kind of looks like it's cutting it in half, so that could be a line of symmetry. But the problem with that, when we do a reflection over a line, we go right towards the line at like a 90-degree angle, and then we go through the line 90 degrees, the same distance. So like, let's say this was point A. A prime would be somewhere out here, which clearly doesn't touch the original rhombus. So choice 2 is no good. All right, and now for choice 3, the reason why someone might pick this is they're going to say like, oh, the y-axis is a line of symmetry. So the y-axis, this has the letter y in it, y equals 0, but be very, very careful here. If you get to the test and you're like, wait, does y equals a number? So does y equals a number? So like this is like a lot of students during the test, like you're thinking like, is it vertical or is it horizontal? And if you forget, there's like a little trick for the test. Just go to the y equals, write like y equals a number 5, and you'll see y equals a number shows up horizontal. So like I'm not going to dive into the concept, but just know like you could use the calculator as a way of remembering rules when you're at the test. So x equals 0 is for vertical lines, so that's why it's going to be choice 4 and not choice 3. So for the last question of the multiple choice, we have a right triangle question. We have a ladder leaning against the wall. So, you know, like if this is your wall here, your ladder is going to the wall. So this is our wall. This is our ladder. And the ladder is 15 feet. And the ground is like the horizontal segment. And they're telling us the ladder makes an angle of 65 degrees with the ground. So if the ground is here and the ladder is here, the 65-degree angle is here. The 65-degree angle would go here if they said the angle the ladder makes with the wall, but they said the ladder and the ground, so that's where 65 goes. And we want to know what's the horizontal distance from the wall to the base of the ladder. The base just means bottom, so we're solving for this distance x. So once again, if you remember the trig functions, the mnemonic SOHCAHTOA, if 65 is here, this is the side adjacent, and the ladder represents the hypotenuse. So we're going to go with cosine in this situation. So then we do cosine of the angle, 65 degrees, is equal to the ratio of the adjacent side over the hypotenuse. So then x is just 15 cosine 65. So then all we got to do here, we're rounding to the nearest tenth. We're just going to type in 15 times cosine 65, and to the nearest tenth, we're going to have an answer of 6.3. So x equals 6.3. And it's in, like it's in terms of feet, but the answer choices, it's multiple choice. Just look for the number. All right, this is going to conclude the multiple choice section. If you found this video helpful, please click like and subscribe below. If you have any requests, leave it in the comment section, and stay tuned for the part 2s in the next video.